All right. Good morning, everybody. I hope everybody's doing well. Let's see how we did with today's warm-up, getting our brain in the right mode for the rest of the class. So, equity bars in effect. Here we go. Give me the possible values for x. I got student number 7, 2, 3, 9, and 16. Student number 7, what'd you put? Okay, student number 2. Student number 3. Student number 9.
Oh, I don't know.
Okay, student number 16. You don't know what to do. I walked around, there was a lot of people who knew what to do. Anyone have an answer? Sharik?
8.
8? Say it again. 8. The correct answer is 8. So, let's start. A lot of you guys wrote down the correct starting point. So could I have a volunteer read what you wrote down first? I know you got stuck along the way, but what did you write down first? Kadir?
8x minus 1 over 10x plus 2 is equal to 7x over 9x. Plus
Okay.
1 plus 1. Equals 7x over 9x.
Okay. So give me a thumbs up if you started out with that proportion. Okay? Good. Put your thumbs down. And even if you flipped the whole thing, that's still the same proportion. So now, look on your cheat sheet, or use what's in your brain. What supports us actually writing that? What says that we can write that? Because maybe it's just gut instinct that you thought you could do that, but I don't know if we can. There has to be a reason. And so the fact that many of you wrote this down, but don't know why you wrote it down is an issue in this classroom. So you have to know the reason for everything that you're doing. Okay? Sharik, what is the reason that supports this?
Corresponding lengths in similar polygons.
Yeah, it was not a postulated theorem. It wasn't anything formal, but corresponding lengths in similar polygons. You are told that these two triangles are similar, and we talked yesterday briefly about the fact that any lines that I now draw, as long as I draw the same line in both figures, then the lines will be in the same ratio as everything else. And so what is this line called? Right here. What is that called? See, we're supposed to know off the top of our head what it's called. John? A bisector. Do we have evidence that it's a bisector? Maybe it is, maybe not. I don't know. Ziomar? That's called an altitude. That is an altitude. It is the perpendicular segment going to the opposite vertex. That's an altitude. It might be a bisector, but I'm not sure. We don't have the evidence to support it. So what that idea says is that the altitudes will be in the same ratio. That's what allows you to do this. Now we got stuck. You can go ahead and do cross products, but if you do cross products and you multiply 9x times 8x, what do you end up with? 9x times 8x, what does that come out to? Kamoy? Does not come out to 72x. And that's a big difference. It comes out to 72x squared, and then 9x times negative 1 minus 9x. That right there turns this into what type of equation? What is it called when there's an exponent of 2? Everybody in the room knows because you were taught by a master teacher last year. Go ahead.
A quadratic equation.
Yeah, it's called quadratic. So everybody, of course, knew that. Maybe you were hesitant because you were scared. So that's fine. But the problem is quadratics are pretty challenging. You will get the correct answer no matter what. But had you used an idea that you learned last year, a simple idea, you would have made your life 1,000 times easier. And so what simple idea can we use to simplify something before we solve the proportion? Ziomara, what can we do? Oh, and then you said you solved it? Oh, good for you. Did you solve the quadratic?
No, not the quadratic.
What did you do?
Since there's x's on both the numerator and denominator, I simplified them by canceling them out.
Yeah. Cancel out. See, we're entering a dangerous area now, ladies and gentlemen, and you have to be very aware of the fact that it is expected that you know everything that you've learned. And I've talked to you on a number of different occasions that you have to be able to take what you were learned in this classroom, take things that you've learned in the past, and bring things together to create new ideas and new experiences. You see in your homework assignments that you're asked to do things that we didn't talk about in class. That's done on purpose. There is no way that we can cover every possible scenario that will come up. You have to be able to extrapolate. Take an idea and apply it to something else. Synthesize. Take several ideas and put them together. So you learned last year that if you have things multiplied, it only applies to multiplication, and you have the same thing on the numerator and denominator, that they get to cancel out. That's something we actually spent quite a bit of time developing. And so once you cancel these out, now they're gone. Now cross product becomes much easier. This becomes 72x minus 9, and this becomes 70x plus 7, and oh, wow, look at this. 2x equals 16. X equals 8. Remember, the canceling idea does not apply when there is addition. So if you have 2 times 4 over 11 times 4, yeah, you could say 2 times 4 is 8 and 11 times 4 is 44, but then you'd have to divide the top and the bottom by 4 to simplify it. How about just simplifying it by canceling things out? Cancel out the 4 and the 4 and you get 2 over 11. That does not work if you have things added. This is not the same thing. You cannot do that. That does not work. It only applies to multiplication and division. Does anyone have any questions about that? Any questions about today's warm-up? I want to be clear that this is an expectation. It is expected that you can take ideas from all over the place and pull them all together to come to some new conclusion. Any questions or comments? Of course, you've titled today's lesson, Lesson 6.3/6.4. We will be wrapping 2 lessons together into one. Today, we're going to wrap 2 lessons into one. The publisher felt that AA, similarity, should be separated from SSS and SAS. This is my first time teaching it, and I read through everything, and I didn't see any reason why it needed to be separated, so we are putting them all together. In fact, I think it makes more sense to do them all together. So we spent a lot of time in Chapter 4 learning how to prove triangles congruent. And we learned side angle side, side side side, HL, AAS, ASA. We learned 5 different ways to prove triangles congruent. And we did that by gathering evidence and then making congruent statements. We also incorporated the idea of proofs, gathering evidence and then coming to a conclusion. Today we're going to start learning how to do something along the same lines, except instead of congruence, we're talking about similarity. You should have your cheat sheet out. Remember, cheat sheet, these ideas need to be utilized and then they need to sink in so that you no longer need the cheat sheet. So our objectives today are to prove triangles are similar by using AA, SSS, or SAS, and then to use similarity to solve problems. And there's no new vocabulary really, but we're going to be incorporating vocabulary that you've heard before. So there are several ways. AA refers to angle-angle. SSS is side-side-side. SAS is side-angle-side. But now we have an issue. Because back in chapter 4, I think, when you learned congruence, we learned side-side-side congruence. Now you're learning side-side-side similarity. So from now on, if you're doing a proof and you have to write a reason and you're going to write SSS, you now have to write SSS congruence or SSS similarity. Okay? So there's a difference. Anyone have any questions about that? So, yes, question? Okay, so let's go ahead and look at what's on your cheat sheet. Angle-angle similarity. If two angles of one triangle are congruent to two angles of another, then the two triangles are similar. Does anyone have any questions about that? Some other ideas should be popping into your head as well. Just automatically. Some other things should be popping up. Anyone have anything that popped into their head as you looked at the diagram? Go ahead. Third angles theorem, that's right. Now, third angles theorem applies to congruence. If you have two angles congruent to two other angles, then the third angles will also be congruent. So of course it makes perfect sense. We can also show that those two are congruent as well. But you don't have to. Now we have a little bit of a shortcut. If you have two angles congruent to two other angles, you can automatically say that the two triangles are similar. Any other questions or comments? All right. Side-side-side similarity. If the corresponding side lengths are proportional, then the triangles are similar. To prove this, you have to show all of the corresponding sides are in the same ratio. And so you would have to demonstrate all of this to be able to make the statement that triangle ABC is similar to triangle DEF. Any questions about that? All right, and then side angle side, similarity. If you have an angle in one triangle congruent to the corresponding angle in the other, and you have the sides that form that angle proportional, so this angle is an included angle, then you can also say that the triangles are similar. Any questions? It'll make much more sense when we do it. Go ahead.
Is there like no sign to represent like two sides like are proportional?
Is there? I didn't hear the beginning of what you said.
Is there like a sign like if they're congruent, like a tick mark? Is it like
Oh, no, you have to show it by actually writing down a statement like this. So that's the part, that's your role as a geometry investigator of gathering evidence. And so this is a piece of evidence, like you're saying, but there's no mark that you can put that shows that it's proportional. If I did this, that would mean that those were congruent. At least I don't think there's a mark that you can put. I'll look it up though for you. That's a good idea. Okay? For now, we're going to have to make statements to show that they're proportional. Okay? Any questions about that? So what I don't want when I refer to the cheat sheet is for you to completely shut down, start getting distracted by something else, and then not engaged at all because I've done the work for you. That I've talked to you about before. That's the bad part about the cheat sheet. Okay? Any questions? Good, so let's jump in and start working. All the diagrams today can be sketches, so you should not pick up the ruler to try and draw the picture, but you should try and draw a picture that has accurate information. You don't need to copy the text of any question. And as I've said before, largely what we talk about here and what we need to be able to do is explain. Support your answer with evidence. Support your reasoning with evidence. Now, in example 1a, I've kind of let the cat out of the bag. In parentheses, I put that we're going to use the AA similarity postulate, angle-angle. So I would like us to try and use angle-angle similarity to prove these two triangles are similar, but I don't know if we can. So let's gather evidence. For angle-angle similarity to work, we need two pieces of evidence. We need two pairs of corresponding angles congruent. So can someone give me one pair of congruent angles? One pair. Stephen? Okay. And since there's only one angle at this letter, you could just say angle D and angle G. Okay? But you can actually absolutely make the statement that angle D is congruent to angle G. There's a right angle indicator, so we know that they're both 90 degrees, they're congruent to each other. Now we need another pair of congruent angles. Is there another pair? Can someone give me another one? Nathaniel? Angle C and angle K. All right, so angle C, I see here, is 26 degrees, but I do not see it here. So I'm not sure how you've come to that conclusion that those are congruent. We need actual solid evidence to support it.
Yeah, that's what I was
Go ahead.
I was going to support it by using the triangle sum theorem. Like, I'm 9 degrees and 64 together, on the other,
Oh, okay, and what is, so then what is it?
26.
Oh, it actually comes out to 26? This right here is 26? Oh, okay. So look at that. So angle K and angle C are congruent. And how did you do that? What was it called?
Triangle sum theorem.
Oh, the triangle sum theorem, right. So you can find the third angle by using the triangle sum theorem. Oh, okay, that makes perfect sense. And so now we can say that angle C is congruent to angle K, and now we've got the two pieces of evidence that we needed. Piece of evidence. AA similarity only requires two pieces. Now we can make a similarity statement. But remember, the order of your letters matters. So if I start out by saying triangle CDE is similar to triangle, and I want to say the second triangle, I have to find the corresponding angle to C. Nathaniel just did that for us. Corresponding angle is K. And now I need a corresponding angle to D. Corresponding to D is the G. And then the last letter is H. And so now we have a similarity statement. That's this right here. That's our similarity statement. And we've explained and supported our reasoning by showing this right here. And I love how Nathaniel came up with the 26 degrees that was missing right here by using the triangle sum theorem. Anyone have any comments or questions on how we prove that these two triangles are similar? Any concerns, any issues? So let's develop the idea a little bit further. Remember, a sketch of the picture will be good enough. So I also, again, let the cat out of the bag. We're going to try and use angle-angle similarity. So we need two pieces of evidence. So help me gather evidence, my investigators. Can someone give me a piece of evidence that we can use? Go ahead, Extol.
Angle ABE and angle BCD.
Are, okay. So angle ABE, and yeah, we have to call it that. So angle ABE is congruent to angle BCD, you said? BCD. Yeah, that's clearly marked, both 52 degrees. Okay, what about another piece of evidence? We need two. And angle-angle means we need another pair of angles. Anything? Extol, go ahead, you're on a roll.
Because they're both like that one says 52 and the other one says 52. They're parallel. So AD is transversal. So you can use AB and EDC.
That was absolutely phenomenal, what he just did. The converse of, I don't even remember what the theorem is, but because these are corresponding and they're congruent, that now means that they're parallel. Remember, it works both ways. If these two lines are parallel and we have a transversal, then that means that they're congruent. If they're congruent, then we know that they're parallel. Now he went to the other side. Now we can say that AEB is congruent to ADC because the lines are parallel and those are corresponding angles. Absolutely brilliant. Absolutely brilliant. Angle AEB is congruent to angle, well, I guess you started with the B, so we could keep with that EDC. And so now we've got the two pieces of evidence that we needed. We actually had a third piece of evidence, if we needed it, that was kind of easy, and we missed. Kamoy? Yeah. How would you say that? Angle A is congruent to angle A by what? By what? Yeah, it's reflexive. Yeah, angle A is congruent to itself, and Kadir's kind of chuckling now, realizing, well, that was pretty easy. If you missed it, here's what you can do. If you draw, instead of drawing this picture as it is, if you are asked at any point to prove two triangles similar, and they're on top of each other, then what you can do is draw them separately. So let me draw this. This is going to get a little messed up, but that's okay. So now I have this, but I also had another triangle right here. And if you label them separately, not perfect, but close enough. If you label them separately, look at what happens. We end up with A right here and A right there. This is 52 degrees, and this is 52 degrees. A is congruent to itself, so you could say that because of the reflexive property of congruence. So we had yet another way to get the evidence. Does anyone have any questions about that? So now we can make our similarity statement that triangle AEB is similar to triangle, and now we got to be careful about our letters. It's got to be A, but then it has to be D and C. And And so now we have a similarity statement with evidence to support it. Does anyone have any questions or concerns about what we did? Anything at all? Now keep in mind, and again, I'm saying the same thing over and over again, you are expected to now take this idea and apply it to something you've never seen before. So keep that in mind as we work through today. Checkpoint number 1. Determine whether these triangles are similar. If they are, write a similarity statement and explain your reasoning. An explanation can be just showing the evidence. Okay? So, you got 2 minutes. Go ahead and begin. Okay? Give me a thumbs up if you were able to prove that the triangles were similar. Thumbs up if you were able to prove it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Put your thumbs down. Yes, they are similar by the angle-angle similarity postulate, but now we need the evidence. Making the statement's no big deal. What's the evidence? Can someone give me one piece of evidence? One piece of evidence. Stephen? Okay, so this angle is congruent to this one. How do you know that? Vertical angles, congruence theorem. Very good. So that's one angle. Now we need another one. What's the other one that we can do? Another piece of evidence. Sebastian? Angle R is congruent to angle T. That right there is congruent to this. How do you know? Very good. Alternate interior angles. You have parallel lines here. This is a transversal. These are alternate interior angles. They are congruent. You also could have done S and U by the same reason. And that is the evidence. You needed 2 pieces of evidence to make the conclusion. Anyone have any questions, concerns, or comments about that? Good. We're doing well. Now let's build our toolbox by putting in 2 more tools. SAS similarity and SSS similarity. And this is going to require a little bit of a shift in thinking. to use SAS or SSS, we have to demonstrate ratios are equal to each other. And we also have to identify corresponding sides. So we have no angle measurements at all, no indications that we have congruent angles at all. So we can't use angle at all. In fact, I'm not sure if we could use side angle side at all. So let's start with the sides. So can someone give me a pair of corresponding sides? Which sides correspond to each other? Just a pair of corresponding sides. Stephanie, give me a pair of corresponding sides. PQ and RQ are not corresponding because they're in the same triangle. I'm talking about one from one and one from the other. I know I put you on the spot a little bit. That's okay. Okay, RQ and S what? RQ and SU are corresponding. You're getting totally thrown off by one, the pressure, and two, the idea of corresponding. Corresponding means the same position. It doesn't mean the same value. So you're not looking at value, you're looking at position. So what I would advise for you is when you draw this picture, don't draw it the way it is. Flip part of the picture around so that it makes a little more sense. Kayla? Okay, so PR and SU are in the same position, different shape, different part of the diagram. And so they are corresponding. And so we're trying to prove these are similar, so what we want to do is make a ratio out of them. So we can start with the smaller triangle and then go to the bigger one, or start with the bigger one and go to the smaller one. It doesn't matter, but now you have to stay consistent. Okay? PR corresponds to SU, and so we want a ratio out of that. And the ratio is 2 to 3. Can I have another pair of corresponding sides? Another pair of corresponding sides. Kalasia? Okay, RQ and UT are corresponding. So now make a ratio out of that. RQ is 3 and UT is 4.5. Put it in simplest form. What does it come out to in simplest form? Nathaniel? Comes out to 2 over 3. So we can see that the ratios are equal to each other, but we have to show all of them. So we need the last pair of corresponding sides. Last pair of corresponding sides is what? Alexander? Good. PQ and ST. And I love how you got the letters in the right order. That was excellent. And so we end up with the same ratio that we had a moment ago, 3 over 4.5. And you can see already that that's 2 over 3. And now we have our third piece of evidence. All 3 ratios are the same. 3 pieces of evidence are needed to say SSS, similarity. And so now we can make a similarity statement. We can say triangle PQR is similar to triangle, and now I need to get the letters right. And since it's isosceles, we could probably flip it around. So let's say STU. And they're similar by the SSS similarity postulate, or similarity theorem. Gather your evidence, and then you can make the statement. Have to have all the evidence necessary. Otherwise, your case gets thrown out by the judge. Anyone have any comments or questions about that? Any concerns? Okay. So I would like us to show, to prove, verify that these two triangles are similar. And again, I've let the cat out of the bag that we're going to try and use SAS or SSS. So now I'm going to leave part of it up to you. Take a minute with your team and try to figure out what evidence you have and which theorem or postulate it supports. So take a minute, team talk, and see what you can figure out. Go. I got some people already writing some things down, putting down some evidence. That's pretty good. I heard some ideas already floating around. Okay, so let's start out with what you and your team thought we would use to prove this. Which theorem or postulate do you think we can use? Alexander? You think your team came up with SAS, John?
We came up with SAS.
SAS? Valerie, what did your team think? SAS? Okay, so let's gather the evidence. SAS means we need an angle. So could someone give us the angle that are congruent to each other? Stephen? Okay, angle TXU is congruent to angle VXW, you said? VXW, and why are they congruent? Vertical angles. So now we've got one piece of evidence, but now we need the ratios of the sides that form those two angles. So could someone give us one pair of corresponding sides? Come on. Okay, so now we've got WX and UX. And so let's see what that ratio is. We've got 20 over 15. What does that simplify to when you simplify it? Kadir? 4 over 3. And what's the other pair of corresponding sides that we need to use? We got WX and UX. What's the other pair? Valerie? Okay, we got TX and VX. Very good. TX and VX. Oh, but before we did the flip-flop, so let's just flip that around. We put the bigger triangle first, so let's just put the VX over the TX, but still same idea. And now we've got the measurements of 16 over 12, and what does that simplify to when you put it in simplest form? Nathaniel? 4 over 3. And so now we have our evidence. We've got this, one piece of evidence, two pieces of evidence, three pieces of evidence. Yes, Kadir?
And just say like if you get like flip before they were flip, right?
Yep. If you flip this around and put 3 over 4 and 3 over 4, it's the same thing. It's just expressed a little bit differently. Okay? So now we can make a similarity statement. We can now say that triangle TXU is similar to triangle VXW by the side angle side similarity theorem. Anyone have any concerns or issues? You guys did very well. So now let's see how you do completely on your own. Checkpoint number 2. Remember the thing I keep saying over and over again. Got 2 minutes. You have 1 minute to compare your answers with your teammates or to finish up. All right, let's see what we got. Stay on your toes. Here we go. I got student 9, 20, number 1, number 17, and number 13. Student number 9, what'd you put?
1 and 2.
Okay, student number 20, what'd you put?
1 over 3.
Okay, student number 1, what'd you put?
Oh, 6 and 2/3.
Got 3 different answers fooling around. Student number 17, what'd you put?
1 and 2/3.
Student number 13, what'd you put? Okay, we got all kinds of different answers. The correct answer is 2/3. So you would have helped yourself a lot if you had heeded my advice from earlier, which was if you have overlapping shapes, don't draw it like that. Separate the shapes so that you can see it more clearly. Because if you had done this, could someone tell us what is this measurement right here? What's that measurement, Valerie? 12. That measurement is 12. This measurement is missing. Now we have the other triangle, and now we can actually get rid of this to see a little bit better. Now if I gave it to you like that, would you have any problems? First you have to demonstrate that they are similar. So let's back up. Can you demonstrate that they're similar? I think most of you assumed that they were similar, but you didn't spend the time to prove it. Eric, did you prove that they're similar? Can you prove that they're similar? Anyone? Can you prove that they're similar? Let me ask it differently. Put your hands down. Give me a thumbs up if you can prove that these two triangles are similar by one of these ideas. Give me a thumbs up. Okay, Stephanie, which idea? SAS, okay. Alexandra, which idea? AA, okay. Stephanie T, which idea? AA, okay. Yeah, it can be done, I think, I'm not sure if it could be done both ways, but definitely AA, maybe SAS, I'm not sure. What are the two pairs of congruent angles? I could see one right there. Boom, boom. That's easy. What's the second one? The one that Kadir was laughing about before that everyone missed, that you should now not have missed. Alexandra? Angle A is congruent to itself right here. So you got two angles. That means the triangles are similar. Now you can proceed and find x. You had to do that first. So some of you made the assumption that they were similar. You cannot do that in this classroom. The answer does come out to 6 2/3. Anyone have any questions or concerns? So we are going to get cut short, but we're going to begin this process of now incorporating the idea of similarity within a proof. So it is unfortunate we'll get cut short, but we're going to spend a few minutes. So example 3, writing proofs. And in this case, you do need to write the given, the prove, and sketch the diagram. So take a minute to do that. And yes, that does say 3UT equals 5RT and 3VT equals 5ST. You'll notice that there's no bars over the letters. So those are not objects, those are values. So ideally, we would spend some time writing a proof, but we're not going to have time to do the proof. So let's focus on the evidence gathering aspect of this. We need to gather the evidence, then you would write the proof using a chain of logic. So we can use AA, SSS, or SAS based on the evidence we have. We have this diagram and these two given statements. So now gather some evidence. You've got 3 minutes with your team to try and gather enough evidence to prove the two triangles are congruent. I don't need a proof. I just would like statements of evidence. Go.
I put on UT for RT.
Fits the jig. So we know two decide to use SAS since those two decide to cover that we can use the vertical STR. Which angle STR would be? Huh? That's what I'm saying. You STR with the yeah, UT. We can use SAS and then use the over side. Okay, that's pretty much.
That would be
I should say we use SA over side.
You know 6.3 and 6.4, if you add up all the numbers, 6 plus 2 plus 4, 12 plus 3 equals 15, 15, wait. No, oh wait, never mind. I thought it added up to 21. No, wait, never mind. It added up to 19. I'm stupid.
Three of the team is over 5.
Wait, I don't think it's proportionate because like it's not the corresponding side. Is it? It is. Oh, no,
I think it's 5,000.
Okay, what evidence were you able to gather? What concrete evidence could you gather? Kamoy, start us off. Okay, by what? Okay, so we got that angle right there. So we got one piece of evidence. That's good. So maybe can we do AA? Can we find another angle and then do AA? That would really be, right, two pieces of evidence. I heard some really great statements. I heard someone say, well, we don't have the parallel line indicators, so we can't do that to say that the car, their alternate interior or anything. That was really great that you figured that out. Really very impressed. So AA doesn't seem like it's going to work. So it looks like we're going to have to somehow utilize these. Okay? Anyone able to figure out how to use those? Sharik, and then we'll go to Kamoy.
Since 3 UT equals 5 RT, and since 3 VT are equal to 5 ST, since with the corresponding, since when you measure them with the corresponding angles, they're proportional, since every 3 UTs 5 RT, since the scale factor then is 3/5, you can prove those two lengths proportional, proving that.
Okay. Well, I'm sort of following your logic. You're throwing in some words that didn't apply at all, like you threw in the word angle and you lost some people. Okay? But there is definitely something to do here with this statement And you're going to have to figure out how to manipulate that. 3ut equals 5rt. Well, let me just propose something. What if it said 3x equals 5y? Is there a way to rewrite that? In fact, there's many ways to rewrite it. Can someone give me one thing we could do to 3x equals 5y that we're allowed to do? Anything that you're allowed to do algebraically. Kadir? So using what property?
That was metric.
That's a symmetric property. So that didn't really change anything. It's just flipped it around. Can we manipulate this in any way? Go ahead.
You can divide both sides by 5.
Okay, so you guys got to pay attention because nobody caught on at all. And so I'm going to have to help guide you a little bit. If we divide both sides by 5 here, we now end up with a new statement, but it's still equivalent. Y equals 3/5 x. So now let's back up the idea and apply it to the geometry statement. If I divide both sides by 5, this 5 will disappear. And now I'm starting to see the 3/5, but we got to figure out how to get rid of the ut. All right, so I apologize. I definitely was hoping we would spend more time on this, but I'm way out of time. So let me get to your homework, and then we'll incorporate this into something else. Your homework is on 2 different pages because we did 2 different sections. On page 378, you're going to do numbers 20 to 24, numbers 31 and 34. 31 and 34, not optional. Page 385, you're doing numbers 7 through 13 and 18 to 23. 33, A, B, and C, and 35 is a 4-point proof. Total, this is 27 points, and that's 3 points there and 4 points here. Then read the next section or do the at-home tutor, and you will have a quiz next week.